Hi everyone, my name is Amitesh, and in this video we're going to show how to graph y equals sine x and y equals cosine x right from scratch. So we're assuming you know cosine and sine x, but even if you don't, I'm actually going to review it in the process of graphing it anyway. So let's just dive right into it. And I've done a video on what sine and cosine are, and if it's uploaded at the time of watching, you can check that video out. Links will be in the description. But let's kind of first think about what cosine and sine are. So the idea behind cosine and sine is we draw the unit circle in the xy plane. Okay, so we have the unit circle, and here what we do is we take, so unit circle means the radius of the circle is 1. So I can kind of draw this by saying that the radius is going to be 1 like this. And what is the definition of sine theta and cosine theta? So the definition is that if you have an angle of theta, right, if you have like an angle of theta here, then what you do is you say that the x coordinate of the point is cosine theta and the y coordinate of the point is sine theta. And this works for every angle between 0 and 360. So you can define cosine theta and sine theta that way. Okay, so what I'm going to do is I'm also going to think about this in terms of radians, because that's the way we really get used to the graph. So I'm going to work in radians, but I've done a video on that too. So links will be in the description for all relevant videos. But the idea behind radians is super simple. Okay, so if you're not comfortable with them, I'll just explain it to you in a very simple way. It's just measuring angles by how far you're going along the circumference of the circle. So kind of the degree measurement is an arbitrary numerical measurement. You know, we sort of say 90 degrees is the angle between the y-axis and the x-axis, but why 90? 90 is arbitrary. But radians is just saying like how much distance would you have to travel around the circumference, and that's really a good measure of angle. It's much more natural. And we know that a circle of radius 1 has circumference equal to 2 pi, right? 2 pi times the radius is a circumference. That's the definition of pi. You know, pi is defined to be the ratio between the circumference and the diameter. So if the radius is 1 and the diameter is 2, the circumference is 2 pi. So an angle of 90 degrees will be pi over 2 radians. An angle of 360 degrees will be 2 pi radians. It's just measuring angle by the circumference of the circle. So that's kind of going to be important for graphing sine and cosine, because it's going to give us our x coordinates, okay? Now the next thing is, let's just kind of start off with the graphs, okay? So we have y equals sine x. Now sine x, well, basically what happens, if we sort of track around the circle, you know, sine 0, right? So this is going to be 0 radians, this is going to be pi over 2, which is 90 degrees. This is going to be 3 pi over 2. Oh, sorry, this is going to be, this is just going to be pi, not 3 pi over 2. Pi is going to be 1/2 2 pi, which is the full circumference. So this is going to be pi. Then this is going to be 3 pi over 2. So that's going to be the radians, right? So what we can do is we're going to graph thinking about it this way. So we're going to start off with sine of 0, right? What is sine of 0? It's the y coordinate of the point that starts off with 0 radians. So this point is the coordinates are going to be 1, 0, right? So sine of 0 is going to just equal to 0. Okay, it's the y coordinate. So sine 0 is going to equal to 0. So I can sort of draw this here. This is going to be sine 0. Now, as we kind of track around, right, as we kind of move our radians from 0 to pi over 2, our y coordinate is going to go from 0 to 1, because at this point at pi over 2, our coordinates are just going to be, because it's a circle of radius 1, right? Its y coordinate is going to be 1, its x coordinate is going to be 0, so it's going to be 0, 1, right? So sine is always the y coordinate of the point. So if we track the radians of pi over 2, sine will be 1. So sine pi over 2 is going to be 1. Okay, so I'm going to actually just draw on the x-axis these radians, pi over 2, pi, 3 pi over 2, 2 pi. So sine is going to be 1 at pi over 2. And it's going to steadily go up. Okay, so it's going to steadily go up to 1. Then what happens when you go from pi over 2 radians to pi radians? Well, when you go from pi over 2 radians to pi radians, sine is the y coordinate. So your y coordinate goes from 1 all the way down to 0, because you hit the x-axis. So here your point is going to be -1, 0. So your y coordinate is going to drop steadily from 1 to 0, and it's going to drop in kind of a circular motion. Okay, so you know it's not like a straight line drop. So you can kind of sort of draw the graph. It's going to be curvy like this, and it's going to be 0 at pi because sine of pi is 0, right? So we're kind of tracking some values. Sine 0 is the y coordinate of 1, 0, which is at 0 radians, which is 0. Sine pi over 2 is the y coordinate of the point which is northmost on the circle, because that's pi over 2 radians. That point y coordinate is 1. And then sine pi is going to be equal to 0. Okay, so we've kind of drawn the graph all the way up to 0, all the way up to pi where sine is 0, and we can keep going with this. So we can sort of do 3 pi over 2. So 3 pi over 2, well, sine is going to become negative now, okay? So this is like an important point. As you go from pi to 3 pi over 2, you're going below the x-axis. So your y-coordinate is becoming negative, and at 3 pi over 2, your point is going to be on the y-axis, so its x-coordinate is 0 and its y-coordinate is negative 1. So you're going to drop from 0 all the way to negative 1, and so we can sort of draw this here. That's going to be sine of 3 pi over 2 is the y-coordinate of the point at 3 pi over 2 radians, which is negative 1. So that is sine 3 pi over 2. That's equal to negative 1. And finally, sine of 2 pi is going to equal to, well, 2 pi is going the full revolution. So you've hit back to square 1. So sine of 2 pi is going to equal to 0. So you're going to go, it's still going to be negative because you're below the x-axis, but your y-coordinate is steadily going to go up to 0. So that's going to be the graph over there, plotted from 0 to 2 pi. And you may ask, you know, what about the other values? What happens to the graph in general? So this is a cool thing. Sine is periodic with a period of 2 pi, because once you go from 0 to 2 pi, you're starting your whole life cycle again. So this graph literally replicates itself every 2 pi units. So you can just kind of take this portion and just reproduce it. So I could reproduce it in the left or the right direction. Okay, so you can kind of let it go up here, and in the other direction, it's going to kind of go like this. It's going to go to negative 1, then 0, then like this, right? So I can sort of draw the graph. It's not perfectly to scale, maybe in this direction, but the idea is this is going to be minus pi over 2. This is going to be pi, minus pi. This is going to be minus 3 pi over 2, and this is going to be minus 2 pi. Okay, so this is going to be your graph, and it's going to keep going. Okay, so it's just what is called a sinusoidal wave. Okay, it's just a wave somewhere. It looks like a wave. Comes up a lot in physics, you know, for example, in harmonic motion, simple harmonic motion. But that's going to be the graph of y equals sine x. Now let's do the graph of y equals cosine x and finish off the video. Okay, so that's going to be pretty similar, and I want you to actually think about it yourself too, you know. So just kind of imagine what you think the graph of y equals cosine x is going to be, and it's going to be a similar process to the one we just did, but we just have to kind of think about the x coordinate now rather than the y coordinate, because cosine theta is the x coordinate of the point that is theta radians along the circle. Okay, so again, we start off with the points. I'm going to now erase these values. We're going to be interested in cosine now. So the x coordinate, when you have cosine 0 radians, you're at the point 1, 0. So cosine theta, sine theta means 1, 0. When you're at 0 radians, you're starting off at 0. Your cosine value is going to be 1. Cosine of 0 is going to be 1, because that's going to be the x coordinate of the point. So this is the difference between sine and cosine. It really starts off at 1 when cosine 0 is 1. So it starts off here. Now what happens to the x coordinate as we go along the circle in radians? Okay, so as we travel this way, our x coordinate keeps dropping, right? Our x coordinate continuously drops until we hit pi over 2. When our x coordinate becomes 0, because we are on the y-axis. So we're at our point 0, 1, cosine of pi over 2 is 0. Okay, so I'm going to write that down. Cosine of pi over 2 is 0, and it has steadily dropped from 1 to 0. Okay, so if we draw a graph here, we're going to get, until it hits pi over 2, it's going to be here. It's steadily dropped. And then our x coordinate, which is always our cosine theta, as we move around the circle, from pi over 2 to pi, our x coordinate goes from 0 to negative 1. Because we're going to the left of the y-axis, our x values are going to be negative, and are going to hit negative 1 at pi. So here we're going to have pi, we're going to get all the way down to negative 1. Okay? So that's going to be cosine of pi is negative 1, because pi radians is the point that's going 1/2 of a circle, which is going to be negative 1, 0, and the x coordinate is always cosine theta. So cosine of pi is going to equal to negative 1. Okay, so that's going to be cosine of pi. And then you can keep going with this. What's going to happen to your x coordinate as you go from pi to 3 pi over 2? Well, it's still negative, right? It's still negative because it's to the left of the y-axis, but your cosine theta is going to hit 0 at 3 pi over 2. Okay, so we can write that down. Cosine of 3 pi over 2 is going to equal to 0, but it's steadily going to go from negative 1 to 0. Okay, so we can sort of draw a graph here. It's going to go from negative 1 to 0 at 3 pi over 2. And then you don't even need to think about this, because you know that 2 pi is 1 full revolution. You know it's going to hit 1, right? When you kind of go from 3 pi over 2 to 2 pi, so you can kind of just say that this is going to equal to, it's going to be 2 pi, cosine of 2 pi is going to be equal to 1, 2. Because 2 pi is one full revolution. Okay, and again, it's the same idea with sine. You know, once you cross 2 pi, you repeat your cycle. So cosine is just going to keep repeating, and of course it's going to keep going. Okay, so it's going to go like this, and it's going to go like this, and it's going to go like this, and it's going to go like this. Okay, so I can sort of draw, this is a cosine wave, you know, it keeps going. This is going to be negative 2 pi, this is going to be negative 3 pi over 2, this is going to be, you know, negative pi, this is going to be negative pi over 2, and that's going to be your graph of y equals to cosine x. Okay, so it's a quick, you know, I've gone a little over 10 minutes, but quick 10-minute introduction to what is the graph of y equals sine x and what is the graph of y equals cosine x. They are absolutely fundamental in pre-calculus and calculus, so I really encourage you to study them and understand them. And you know, it's not something you really memorize, it's something you get used to. But once you understand the process, that's the key. You know, being able to understand the process from the definition of cosine and sine, why the graphs come to be, and being able to explain it to someone, then you know you've mastered, you know, these graphs, and then you can sort of commit them to memory. And the way I like to think about it is just sort of sine, you know, 0, it goes up and comes down like a wave. Okay, so you just sort of have to remember sine 0 is 0, it goes up, then it comes down, and it has to come down and hit the x-axis again. Pi, you know, half of 2 pi, half of a full revolution. And for y equals cosine x, it's the same idea. You just have to remember cosine 0 is 1, and it's going to come down, it's going to hit pi over 2, then it's going to, at pi, it's going to go, you know, all the way to the very bottom, and then it's going to go up top at 2 pi. Okay, so you sort of know it evenly kind of drops by 1 and then, or increases by 1 every pi over 2 kind of units, or radians in this case. So then, you know, once you know what it is at 0, you can kind of predict it. Okay, so that's going to be, you know, the exposition of y equals sine x and y equals cosine x. I hope you loved that video. You know, please like and subscribe. If you've watched this far, it means so much to me. My goal is free accessible math education worldwide at all levels, create a library of math. And why wouldn't you want that? You know, like if you subscribe, you'll have infinite access. You know, I'm uploading regularly. I'm very committed to uploading 5 videos a week. And I'm just, you know, going on uploading at all different levels to cater to as many people as possible. So if you subscribe, you'll have access to all those videos and always be notified of new content. And whenever there's a video that's interesting to you, hopefully as many as possible, you can just click on it and watch it, and you'll just know that it's there. And by subscribing, you also help support my mission of free accessible math education worldwide at all levels of math. You know, I want to help as many people as possible to learn and love math. And I'm doing this from, you know, delivering this education right to everyone's room. And ultimately, I want to create resources for people in underprivileged backgrounds, or, you know, people who don't have the access to the same educational resources to be able to learn and love math. And by liking and subscribing, you help build my channel. So eventually I get to a point where I'm able to have the resources to invest to help even more people. So thank you so much for watching. I hope you loved that video. I wish you all the best wherever you are. Thank you so much. It really means a lot to make this video and to have you watch, to have an audience. And I'm super excited to see you in the next video.